Welcome and thanks for showing interest in our Master of Engineering, Logistics and Traffic. My name is Chris Tampere and I am part of the teaching staff of this Master. I'm affiliated with the Center for Industrial Management of the Department of Mechanical Engineering of the KU Leuven. In this video, I will explain briefly what you learn at KU Leuven in the Masters of Engineering, Logistics and Traffic, who can enroll for this Master, and how your choice for a specific bachelor will affect this. But before I do so, I will first say a few words on the domain logistics and traffic itself, because even though you daily travel and you buy products daily, you may not always be fully aware how many engineering challenges are actually behind these mobility and logistics services. You can look at transportation systems on different levels in which many different players operate, and they are constantly in complex interaction. You have the level of activities of individuals and their activity chains, but also of companies with their supply chain and distribution strategies. This leads to the desire for moving freight and people and many choices related to that. Finally, there is the operational level where flows of vehicles and objects compete for resources in our physical transportation infrastructures. Now, what makes it interesting for engineers is that all the components and players in this system are constantly evolving. We develop changing social interactions, different production methods, economic models. Our political reality and preference change, and there is a changing awareness of ecological constraints like climate or habitat and biodiversity. Moreover, and that is very interesting for engineers, new technologies trigger constant innovation on all the levels shown in this scheme. It's indeed technology that drives innovations and new business models that, were 15 years ago hardly imaginable. For instance, here you see just one link in the logistics machine behind world leader in e-commerce Alibaba. If you click the hyperlink, you will see how in Alibaba's warehouses, robots and humans collaborate to bring your parcel from China to your doorstep in just a few hours or days, and that almost for free. Here's another example where Swiss Post, as one of the first commercial companies in the world, distributes parcels by drone, for instance, bringing urgent medicine to remote patients. And the innovation never stops. Engineers are now trying to transfer the e-commerce technology that moves parcels into the transport of passengers and to offer mobility as a service. It works just like our comic character Lucky Luke, who only has to whistle and then jumps out the window in blind trust, while he knows that by the time he's there, his faithful horse Jolly Jumper will be ready to carry him away from a battle scene. Well, logistics and traffic engineers work on mobility as a service apps, and more important actually, the logistics behind the scene, such that a virtual whistle from your app triggers a fleet of autonomous taxis that are dispatched from a central control room, and that vehicle picks you up and drops you off at your next destination. Tire manufacturer Goodyear has made a very nice visualization of this concept in a futuristic setting with fancy vehicles on spheric tires. Of course, there has to be some innovation for them as well. And you can watch that in this video link. But why do we then need specific quantitative logistics and transport and traffic engineering skills? Well, just like all the great technology shown so far, also the car was and is still a great technological product. But over decades, we have learned how this has not only brought society benefit. A solution that is good for one player in transportation game can indeed have severe negative consequences for climate or for other people using different travel modes, like for instance the bicycle. And even though the car may be a brilliant solution for a single user, in many contexts it scales badly and it loses its attractiveness. Logistics and traffic engineers see this as a game theoretical problem that begs to be managed and controlled better than we do today. And we have learned from existing transportation system how these things work. But likewise, it's of course brilliant if we can save lives by drone delivery of urgent medicine. And it's very sympathetic when robotics engineers enable autonomous pizza delivery at our doorstep or so. But when this scales, society may not accept a city sky that sounds more like a swarm of bees, or that pedestrians are being pushed off the sidewalk by an army of delivery robots. You see, the work is not done when the technological feasibility has been proven. For you as a logistics and traffic engineer, that is exactly where your work starts. Because it requires good analysis, planning, and optimization skills so that Goodyear's fancy advertising picture does not turn into this, but rather into an enjoyable city where autonomous taxi pods have been seamlessly integrated with public transport, with e-steps, with bicycles and walking. So logistics and traffic engineers help giving society more mobility in logistics, even though that same society is ever more aware of the social costs and physical impact and tolerates less the negative consequences on natural habitat, pollution, climate, and so on. If after your study you don't just want cold technology, but you want your engineering skills to help create livable cities and landscapes, to create efficient and resilient supply chains and distribution networks for our enterprises, and all this with respect for human, social, and environmental limitations, well, then logistics and traffic engineering might be your future. Where our colleagues develop the enabling technologies, a master in logistics and traffic knows how to deploy them optimally in what we call intelligent transportation systems, or ITS. We create added value in businesses with this ITS technology, and we design and control system-wide solutions that do scale sustainably. Here's an example of how this may help making smarter decisions. Take, for instance, autonomous driving technology. We might use this to just replace the family's private car as we know it. Engineers in the US have quantified this. They have quantified what happened to our networks, to our transportation networks, if households would just behave as usual. For instance, here in top you see a family living in Atlanta, and the orange blocks are their activities throughout the days. Engineers have computed for this and a million other households how many cars each family would optimally need to bring mommy to work, then instead of parking all day, drive back autonomously to bring the kids to school, etc. This analysis shows that only 80% of the population in Atlanta would have true benefit from this technology and would therefore buy it. But that fleet would run empty 30% of the time, and it would lead to 13% of extra vehicle miles traveled, especially on the smaller roads exactly where these families live and their kids play. We might alternatively use autonomous driving technology and pair it with electric drivetrains and dispatching technology to offer shared e-mobility as a service. It turns out then that for a similar region, in this case Houston, the total fleet size may reduce by half, and empty driving would be reduced to 15% of vehicle miles traveled. However, this would require people to be more patient and wait in between 2.5 to 8.5 minutes before being picked up. This kind of quantitative predictions can help end users, but also businesses, infrastructure operators, and governments to take position in the debate on how autonomous driving technology should be deployed in our lives. And once it's there, logistics and traffic engineers will analyze data on how new transportation technologies are being used, how their design, coordination, and control can be further improved and continuously optimized. So what do you then learn as an engineer in logistics and traffic? Foremost, we further develop all your mathematical and analytical skills that you developed in the bachelor's, and we develop into a quantitative toolkit that puts you in a position to optimize all kinds of logistics and traffic processes. For instance, ICT, but also GIS, geographical information systems, statistical processing techniques, game theory, modeling optimization, and operations research. Then we have two domain-specific learning lines. The first one takes the perspective of a single user or company. So here you study logistics, supply chain engineering, and operations research supporting that. The other line is the complementary perspective of the collective or system point of view. Here you study network modeling, public transport design, transportation system design and control. Finally, you cannot detach all this hardcore engineering from its social and corporate context, and that is why you study transport economics, safety and ergonomy, and industrial management. So this also explains the structure of your master. On top in orange, you see some courses building up that quantitative toolkit. To the right in blue, you see the learning line from the user and company perspective. The left in yellow is the collective system perspective learning line. In the middle is where this all meets in the socio-economic and spatial context. If you want more details on any of these courses, feel free to click the link to our site and online program book. The courses that are highlighted now are also part of the minor industrial management, or in Dutch bedrijfsbeheer, part of the bachelor's. If you have followed this minor, you will have 14 credits extra available for elective courses in your master's, and otherwise these red marked courses are part of your master itself. Now, who can enroll in this master? If you're an international student, I refer you to the faculty rules for requirements on language and transferability of your non-EU engineering degree. If you're an EU student, and so especially KU Leuven bachelor students, know that any bachelor or master in engineering can enroll. However, if you already know that you want to study logistics and traffic, we recommend the bachelor combination at KU Leuven, which includes the minor industrial management, so bedrijfsbeheer. Maybe it can have slight benefit to study computer science, mechanical engineering, civil engineering, but in fact, the analytical background from any bachelor prepares you for our masters. Okay, with this I conclude this introduction. Feel free to visit our website or ask any of the staff, including myself or my colleagues Dirk, Lilian, or Peter.